Hey guys, one of the harder topics in biology, curriculum biology anyways, is enzymes and how they work upon our digestive system. So I'm going to talk a little bit about what an enzyme is and then sort of one of the pathways, probably the easiest one, on how carbohydrates, starches, and sugars get broken down. Fats and proteins also have a sort of a chain reaction of getting broken down, but they're a little bit more complicated. So I thought I'd show you the sort of the simplest way, and that might apply a little bit to the other ones as well. So when we look at an enzyme, enzymes are chemicals in the body. So they're made somewhere and they usually act upon close to or somewhere else that speed up chemical reactions. So we typically talk about food breaking down, carbs around 4 hours, fats around 6, and proteins around 8. Again, if we didn't have these enzymes, it would be, days to break down some of those. And again, it depends what form they're in. If they're in liquid form, it's a little bit faster. But, let's say you have a steak, right? It's going to be 8 hours before our body's using all of those amino acids to build up muscle or something like that. Okay, so when we look at a carbohydrate breakdown, when we look at carbs, they are typically built like little cars on a train. They're interconnected. They're in long chains, carbohydrates, so you can talk about sugars or starches or carbs. Those things are all related. We call those polysaccharides. Poly means many. So there's many sugars kind of linked together. So what happens we start chewing in our mouth, there's a little bit of a mechanical breakdown, but we also have an enzyme in our mouth from our salivary glands called salivary amylase. And it starts to snip some of these bonds. So we've got sort of an 8-chain sugar here. Down here, it's broken into 2 4s. So it's got 1 cut in it, all right? It's started to be digested. It'll slow down in the stomach. There's not a lot happening in the stomach for chemical digestion. Then once it gets to the small intestine, there is another amylase in there. This one comes from the pancreas. So we talked about last video. Pancreatic amylase, it starts to snip more of the bonds. So now we've got these sugars down into paired sugars, or what are called disaccharides, are 2 sugars. One of those is one called maltase. All right, a fairly simple sugar, but still not usable yet. Our body can digest it, but we can't use it till we get another step. So later on in the small intestine starts producing maltase. Most of these enzymes end in ASE, but not all of them. Maltase acts upon maltose. And again, it does some more snipping of the bonds between the sugars. So we started out as an 8-chain sugar. Now we've got 8 individual units here of what's called glucose. And glucose is a monosaccharide. That means 1 sugar, monosugar. It's now in the usable form of sugar. It can now go to the body. It goes through the blood. It goes to every cell in the body. Extra gets into our liver to be stored. And what's needed right away will go into our blood and go to all the cells of the body. Glucose is the usable form of sugar. So all carbs, starches have to be broken down, chewed up, chemically digested by enzymes. Then once it's down to glucose, it can then be used. And again, with carbs and starches, if it's in liquid form, it's probably shorter than this, but kind of an average would be about 4 hours. So that's why sometimes you'll see athletes, when they are going to competition, they'll typically have something with some sugar or carbs in it 3 to 4 hours before competition, because then those sugars will be available. And some of it will get stored in the liver. If you start going in your competition, that competition's running long. Let's say a game goes into overtime. Your liver then can put some of that sugar back into the blood, and you should be able to continue to perform for quite a long time. If you're talking 6, 7 hours, no chance. You'd be now going on to stored fat. But a competition of 2 or 3 or 4 hours with a good meal in front, you should be good to go. Take care. Call me if you need to.